So we will start now. My name is Tomasz Chabinka. I work as a senior data scientist at Alior Bank in Poland, and my talk today is about embeddings. I just start a timer so I know where I am, I want to talk about like two dimensions of this technique. One is dimensionality reduction, and the second is feature engineering. The plan for today's talk is to talk about dimensionality reduction, about feature engineering, about how to actually train embeddings with word-to-vec algorithm, growth algorithm, and for recommender systems, and then how to use it with TensorFlow. I have two bonus sections, but I'm not sure if we will have enough time for that. We will see. So let's start with like a motivating example. So let's say we are building a model that will help us to like assess the sentiment of reviews. So we have a text, and we want to tell how many like stars a person give for some book, for example. And it's like not easy task, I would say. It's like people tend to like use sarcasm in reviews, tend to like write long sentences. So it's pretty hard. And like the traditional way to like work with text data is to create a back of word representation of our sentence. So we take all the possible words and we mark which of them actually were present in our sentence. There are two problems with this approach. The first one is that we will have a lot of features. Like if each word is a feature, we will have like around like from 400,000 to above 2 million features. And the second one is that we actually like lack the context of what was written, right? We know that in our sentence we have had like not and great, but we don't know if somebody wrote not great or it was like completely something else. So we can solve our problem with lack of context by like actually hot encoding each word separately, but it will like in result we will have even more features, so it's not good. Like easily we can reach like 2 million features, and it will be really problem to train our model with that. So we could try to use different dimensionality reduction techniques, like subset selection. So we could like not hot encode every word, but only like the words we think or measure that are the most important. Or we can like try to use some regularization techniques, or we can try to use the traditional dimensionality reduction techniques like principal component analysis. But in this problem it won't work very well, unfortunately. So what we can do? We can use embeddings, and we will talk in a moment what embeddings exactly are. But with the help of embeddings, we can reduce the encode each word as a 300-dimensional vector, and in this way we will reduce the number of features dramatically. So if we will take five word context, we will have only 300 times 5 features instead of 2 million. So we will gain a lot. And as a summary for this section, I wanted to compare like the popularity of different techniques for dimensionality reduction. And as you can see, so word-to-vec and globe are like types of dimensionality reduction, embeddings techniques for natural language processing. And as you can see, word-to-vec is like quite popular now. It's as popular as lasso technique. The globe is not so popular, and like the partial least squares, this is like the PCA for supervised learning, is not very popular. But then when we like compare all these techniques with PCA, we see that PCA is still the king in this world. Okay. So that was like the first motivating example, and now we will see how it works with feature engineering. So in this case, let's say we are building like a discount coupon application, and we want to predict to which users we should grant coupons we have in this application, and usually we will want to like grant coupons for similar things that user bought in the past, let's say. So one approach would be to take every like thing that user can buy, right, and try to describe it, like create some manually some features, right? So you can like try to grade your things on the scale from like good value to money to premium, or on the like scale from popular to prestigious. The problem with this approach is that actually it's quite costly to describe each item, right? You will need to have a lot of time to like take every, I don't know, shop where user buy things, or every brand, and try to describe it. And the second problem is that you will need to have a lot of expertise. I mean, for example, these descriptions probably doesn't make sense, right? It's there is no a lot of knowledge in it, so you would need to have expertise to describe each brand. So it's difficult and costly. So what embeddings actually do is embeddings try to find dimensions that will describe the data for you. And to do that, like like basically you give them categorical data, you show algorithm how to like measure similarity of like things, and then like the embeddings learn how to represent your items in lower dimensional data in a way that like the similar things are similar to each other. What is interesting is that actually when embeddings are created, there are like some interesting relations. I mean, you have vectors, and you can execute some calculations on these vectors. So when you have a vector for Samsung, Apple, Toyota, and Mercedes, you can, for example, add Apple to Mercedes and remove Samsung, and you will see that like the brand in relation to Samsung, that is like brand in like Mercedes to Apple is Toyota, right? So it's like imaginary example, but it's kind of how it works. Okay, so that's what I told. Okay, and in terms of like the formal definition, embeddings is a way, like the categorical feature represented as a continuous value feature, so a vector. And embeddings are like part of the embedding space, that is the dimensional vector space that features from a higher dimensional vector space are mapped to. Okay, so how to actually create embeddings, and like the part of the word that it's like most popular, as we've seen at the beginning, is the in the natural language processing field. So I think like one of the first and like the most important, most known algorithms is word2vec, and to create it, you build a task in which, based on the couple words before a word and couple words after the words, you try to predict what is this word, right? It's like the small neural networks, let's say, with no deep layers, just one layer. So you have one encoded, like the words, and you learn what weights should be put to these inputs to predict the output correctly. And the second similar task is to like try to, based on the input, predict the words in the close neighborhood. And when you like create this kind of machine learning tasks and you train it, you just take these weights and like the projection, and this is what we call embedding. The second approach is what is called growth algorithm. So in growth algorithm, you have like your database like with text. So you have corpus of text, and you try to like count each pair of the words that is together with the in one sentence. So this is like the left side of this equation. And if you have, when you have all this probability, for example, like probability that cat will be in one sentence with potato or with pet, you try to find vectors k, that k times k will give these probabilities. So this is a second approach. This is, I think, newer and quicker than the previous one, but probably like a bit more complicated in mathematical terms. And the third approach to training embeddings is to like in recommender systems. So you can have this kind of neural networks where in the input you have like the hot encoded user shops, like the user shopped in the past, and you try to predict what shops user will be shopping in the future. And when you like train this neural network, you will create this three-dimensional embedding layer that you can take and use for other similar tasks. So why to use embeddings? So the first possibility embeddings give us is to find similar items. the second one is like with embeddings we can calculate relationships between items. So this is like this example I gave earlier about like finding Toyota based on other brands, and I found in the internet some blog post from Sephora that in the similar manner they try to recommend like the lipsticks of their own brand for the buyers of other lipsticks. And we can use our embeddings for transfer learning. So for example, based on like we can create embeddings to predict what the shop's user will buy in, and based on that we can create, for example, some profile of this user, or like what kind of consumer he or she is, and use it in other problems related to finance or to marketing. So I think TensorFlow is like the most popular library now for like the machine learning with when we use neural nets, and like the embeddings is trained with neural nets, so it's like quite popular to use TensorFlow to train embeddings, and it's quite easy. As you can see, you just create embedding column layer in TensorFlow, and you train your classifier. Then you can read this embedding column. You set trainable to false, so this layer doesn't change in the future when you use it for transfer learning, and basically that's it. Okay, so let's see how I'm with the... Okay, so I think I have a couple more minutes, so I will briefly maybe show you other libraries in Python you can use for that problem. So the most popular one, I would say, is GenSim. I even saw some GenSim stickers, I think, at the desk near the reception desk. So it's pretty popular. And with basically it's like the library for text operations. You can create your embedding with your text. You can read with GenSim embeddings that other people created, for example, Google or other big companies, and then you can do some basic operations. So, for example, you can see that when you have you can find in these embeddings that the woman king is actually a queen, right? Or you can see that when you see breakfast, cereal, dinner and lunch, the cereal word doesn't match to the rest. And you can measure similarity between different words. So the thing that it's worth to remember with embeddings, especially in natural language processing, is that they are not perfect. They, like in everything in machine learning, they are just like, this is statistic, right? And like you give machine learning algorithms some corpus text, and in this corpus text, not everything needs to be perfect. So when they actually researchers checked the popular natural language processing embeddings, they discovered that this relation is not always doesn't always make sense, right? So it works good with man, woman, king, queen, but it doesn't work good with man, woman, computer programmer, homemaker or with other similar analogies. So there is a way to solve this kind of problems. So as I mentioned, basically we have some vectors, so we can on these vectors find a vector that is responsible for the bias we have, and we can remove this vector from embeddings, and this way we can reduce bias, but at the same time we still maintain like the utility of our embeddings. We don't break them, they are just working better. Okay, so I think that's all from my side. So if you have any questions, I'm happy to answer them. I also would like you to fill in a short feedback form, so it would be useful for me. Thank you very much.